Ever wondered how calculus impacts your daily life, or what it even is for that matter? Well, let's delve into it. Picture calculus as an exquisite branch of mathematics, a realm where we study the rates of change and how small quantities accumulate. Now, you might be wondering, where does this come into play in the real world? The answer is everywhere. From the physics that governs the universe, to the engineering marvels we create, from the economics that rule our markets, to the computer science that's revolutionizing our lives, calculus is at the heart of it all. It's the secret sauce, the silent partner, the unsung hero, if you will, that helps us understand and navigate the complexities of our world. So next time you wonder why you need to learn calculus, remember it's more than just equations and graphs. It's a fundamental tool that helps us make sense of the world around us. Now, one of the most important applications of calculus is in optimization. But what exactly is optimization? Well, in the simplest terms, optimization is the process of finding the maximum or minimum value of a function. It's like trying to find the highest point on a hill or the lowest point in a valley. Let's consider a few examples of how optimization plays a big role in real-world situations. Picture a production manager in a factory. They need to determine the most efficient way to use their resources to produce as many goods as possible, without compromising on quality. This is an optimization problem. They're trying to maximize production, given a set of constraints like time, manpower, and materials. Or think about an investor managing a portfolio of stocks. They want to maximize their return on investment while minimizing risk. Again, this is an optimization problem. They're looking for that sweet spot where the return is highest and the risk is manageable. Resource allocation is another area where optimization comes into play. Let's say you're in charge of scheduling shifts for employees in a hospital. You want to ensure that there are enough staff members on duty at all times, but you also need to consider factors like employee availability, overtime costs, and the need for rest periods. It's a delicate balancing act, and it's all about finding the optimal solution. In all these situations, calculus provides the tools to find the maximum or minimum values that we're looking for. It helps us figure out how to allocate resources, manage risk, and make decisions that are as efficient and effective as possible. So, whether it's producing goods in a factory, managing a portfolio of stocks, or scheduling shifts in a hospital, optimization is a fundamental part of the process. It's about making the best possible decisions given the constraints we're working with. And that's where calculus comes in. Optimization, powered by calculus, helps us make efficient and effective decisions in various fields. It's not just a mathematical concept. It's a powerful tool that helps us navigate the complexities of our world. And that's why understanding optimization is so important. So, how does calculus help in optimization? The answer lies in derivatives and integrals. Let's start with derivatives. Picture a roller coaster. The derivative at a certain point on the ride shows the rate at which the height of the coaster is changing. If the derivative is positive, the coaster climbs uphill. If it's negative, it's plunging downhill. And if it hits zero, that's a peak or a valley, a point where the coaster changes direction, a critical point. In calculus, we use the derivative of a function to locate these critical points, or places where the function reaches a maximum or minimum value. Now, imagine you're given the task of finding the highest point on the roller coaster, but you can't see the entire ride. By calculating derivatives, you can figure out where the coaster is climbing uphill or plunging downhill, and locate the peaks and valleys, even when they're not immediately visible. Integrals, on the other hand, are about accumulation. If derivatives are about rate of change, integrals are about the total change. Think of it like a savings account. Each deposit or derivative represents a small change, but the total amount in the account, the integral, gives you the accumulated result of all those changes. In calculus, we use integrals to calculate areas under curves, distances, and volumes, among other things. The integral of a function can provide us with the total change over a certain interval, helping us to understand the bigger picture beyond just the immediate rate of change. So, in the context of optimization, derivatives help us find the best or worst-case scenarios, the peaks and valleys. Integrals, on the other hand, help us understand the total impact of these scenarios over a certain period of time or across a certain space. Together, derivatives and integrals provide us with a powerful toolkit for understanding and optimizing complex systems. They enable us to find the best solutions, even when those solutions aren't immediately obvious. Derivatives and integrals, though complex, are powerful tools that calculus gives us to solve problems. Scene script. Let's dive deeper into the optimization process and see it in action. Picture this. You're trying to design the most efficient travel plan for a cross-country road trip. The objective here is to minimize the total travel time, which is our objective function. The constraints might be the total distance you can travel in a day, the number of days you have for the trip, and the cities you want to visit. The first step in the optimization process is to set up your objective function. In this case, it's the total travel time. This function is likely to depend on several factors, such as the distances between cities, the speed at which you can travel, and the time spent at each stop. Next, we set up the constraints. These are the conditions that must be met for the solution to be feasible. In our road trip example, constraints could be the total number of miles you're willing to drive each day, the hours of operation for attractions you want to visit, or the amount of time you want to spend in each city. Once we have our objective function and constraints, we can use calculus to find the optimal solution. This is where derivatives come into play. The derivative of the objective function tells us how the total travel time changes as we adjust our route. If the derivative is positive, adding another city to our route will increase the travel time. If it's negative, it will decrease the travel time. By setting the derivative equal to 0, we can find the points at which the travel time is at a minimum or a maximum. These points are known as critical points. We can use the second derivative to determine whether these points are minimums or maximums. If the second derivative is positive, the point is a minimum. If it's negative, it's a maximum. This process, repeated for all variables and constraints, gives us the optimal solution. For our road trip, this would be the route and schedule that minimize the total travel time while meeting all our constraints. And that's how we use calculus to find the optimal solution in a given situation. Calculus might seem daunting, but its importance in today's world cannot be overstated. Often, the word calculus conjures up images of complex equations and intricate graphs. While it is true that calculus can be intricate, it is also an incredibly powerful tool that has revolutionized many fields. The use of calculus in optimization, for example, has completely transformed sectors such as physics, engineering, economics, and even computer science. Let's take a moment to delve into this a bit further. Optimization, as you may already know, involves finding the maximum or minimum value of a function. This is a common problem in many real-world scenarios. For instance, businesses use optimization to plan their production schedules, allocate their resources, or manage their portfolios. Now you may be wondering, how does calculus fit into this picture? Well, calculus provides the mathematical tools needed to solve these optimization problems. By using derivatives and integrals, we can pinpoint the critical points and determine the nature of extrema. This process involves setting up an objective function and constraints, and then applying calculus to find the optimal solution. This application of calculus has been nothing short of revolutionary. For instance, in economics, it has allowed analysts to model and predict market behaviors with increased accuracy. In computer science, calculus is used in algorithms that power our digital world, from search engines to artificial intelligence. But the impact doesn't stop there. The power of calculus extends well beyond professional fields into our everyday lives. It helps in predicting the weather, in medical imaging, and even in the design of more fuel-efficient cars. The list of applications is endless, emphasizing the importance of a strong understanding of calculus. It's not just for mathematicians or scientists. In today's world, anyone seeking to work in fields that require optimization, which is almost every field really, needs a firm grasp of calculus. Calculus, thus, remains a crucial area of study in mathematics education. So, we've seen how calculus, particularly through optimization, impacts our daily life. As we've discussed, calculus is a branch of mathematics that deals with rates of change and the accumulation of quantities. It's a versatile tool, with applications in physics, engineering, economics, and computer science. We've also touched on the role of derivatives and integrals in finding the maximum or minimum value of a function, a process that is crucial to solving optimization problems. Whether it's planning production, allocating resources, or managing portfolios, these problems are everywhere. The optimization process itself involves setting up an objective function and constraints, and then using the tools provided by calculus to find the optimal solution. It's a process that has revolutionized decision-making in many fields, making them more efficient and effective. So, calculus isn't just about solving equations, it's about solving real-world problems. And who knows, the next problem it solves could be yours.